All right, so question 22. So we need to use a little bit of a trig identity here. So you have the cosine of 2x, which is the one that equals like 7,000 different things. So let's see what would be the best choice for cosine of x here, right? So in a sense, we want to choose something that ends up easily square rooted. So notice that I have a 1 minus something. So if you look back at the cosine 2x rules, right, we have cosine of 2x, which is equal to 1, 2, 3 different things. Which one do I want? Well, I have 1 minus something. So if I look at this one here, 1 minus 2 sine squared of x, oops, that's just a random graph, awkward. So if I look at changing this to 1 minus sine squared of x, well, now what ends up happening is that I end up with 1 minus 1, which cancels out, negative times negative. We're going to get a nice little cancellation here. So this is going to turn into just sine squared of x. Right, so sine squared of x is under our integral. So there's a 2 sine squared of x there, my bad. So there's a 2 sine squared of x in there. So I can look at this integral from 0 to pi over 4 as now the square root of 2 times the square root of sine squared of x dx, which I can pull this square root of 2 through our integral because it's just a constant. Derivative of sine squared is just sine of x. All right, so when I take the antiderivative of sine of x, we know that sine comes from a negative cosine. So I'm going to get negative radical 2 cosine of x evaluated from 0 to pi over 4. And then we can just plug in what we know, right? So I have negative radical 2 times the cosine of pi over 4, which is just rad 2 over 2, minus the cosine of 0, which is just 1. So I get negative root 2 times root 2 over 2 minus root 2 times 1. So this is going to be radical 2 times radical 2 is just 2. So we're going to get negative 1 here minus root 2. So that should be our definite integral.